Okay, picture this. July 1969, the United States lands a man on the moon and safely returns him to Earth. The Apollo 11 triumph is absolutely etched into our collective memory as humanity's greatest leap. We all know the images, right? And we definitely all know those famous words. But what if I told you the mission that actually made those famous footsteps possible is one you've probably never even heard of? Today, we're looking past the lunar landing to uncover the forgotten linchpin of the entire Apollo program. There was no crew, there was zero public fanfare, but it was absolutely vital. We're talking about Apollo 4. Now, to really understand the immense stakes of Apollo 4, we have to look back at the unimaginable tragedy that preceded it. During a routine ground test for Apollo 1, a fire broke out inside the command module, tragically claiming the lives of 3 astronauts. In an instant, NASA's frantic race to the moon came to a devastating dead stop. See, before this happened, earlier test missions were just using smaller rockets. They couldn't come close to replicating the brutal conditions of a lunar return. But the Apollo 1 fire forced NASA to step back and re-examine literally every single aspect of the spacecraft's design. It caused massive delays, for sure, but this grueling redesign phase became the exact crucible that would ultimately save the entire program. Because NASA didn't just tweak the design here, they completely tore it down and started over. They integrated heavily fire-resistant materials, entirely upgraded the internal wiring, and installed vastly enhanced safety systems across the board. They had to ensure a tragedy like that would never, ever happen again. But this created a massive dilemma. How on earth do you test a totally redesigned spacecraft, not to mention the most powerful rocket ever built, without risking human lives all over again? NASA desperately needed a full-scale demonstration to prove their new hardware was actually ready. Enter the Saturn V. This thing was a beast, standing over a staggering 100 meters tall. To put that into perspective, that is taller than the Statue of Liberty, and weighing thousands of tons. This wasn't just a rocket, it was an unprecedented, monstrous engineering marvel, built to push the absolute outer limits of human capability. And just getting that immense weight off the ground required 3 distinct stages igniting in perfect, flawless sequence. Stage 1 used 5 massive F1 engines just to clear the launch pad. Stage 2 continued the brutal ascent, and finally, Stage 3 handled the orbital insertion. If even one of these stages failed on its very first try, the moon landing was effectively off the table. So the moment of truth finally arrives on November 9th, 1967. As the countdown hits 0, the Saturn V ignites. The thrust was so unbelievably massive, the ground at Kennedy Space Center literally shook. And stage by stage, the rocket performed flawlessly. The launch was a resounding, absolute success. But reaching orbit wasn't even the primary goal of this explainer. The true test of Apollo 4 was still waiting in the wings. Could that newly redesigned command module survive the ultimate trial of returning all the way from the moon? Look, re-entering the atmosphere from a standard Earth orbit involves pretty manageable heat and stress. But returning from the moon? That is a violently hostile environment. The spacecraft slams into the Earth's atmosphere at extreme speeds, creating just unimaginable friction and pressure. We are talking about temperatures pushing 2,800 degrees Celsius. That is half as hot as the surface of the sun. The heat shield had to somehow absorb and dissipate this terrifying amount of energy. If it cracked even a fraction, any future crew inside would be instantly incinerated. To actually test this without putting a crew in danger, Apollo 4 was deliberately propelled out into a high elliptical orbit. Then it turned right around to dive bomb the atmosphere at extreme lunar speeds. And the result? Total success. The shield held, the parachutes deployed exactly as planned, and the spacecraft splashed down safely. It's hard to overstate this, but this single uncrewed test changed everything. Following the Apollo 1 tragedy, confidence inside NASA was understandably at rock bottom. But post-Apollo 4, morale absolutely skyrocketed. NASA proved they had learned from their catastrophic mistakes and built a vehicle that was finally ready for the ultimate journey. Apollo 4 really marks the definitive transition from theory to reality. It was the exact moment the Saturn V moved from being this super ambitious paper design to a highly functional working machine. Suddenly, the moon wasn't just a dream. It was tangibly within reach. From there, progress just exploded. NASA refined a few more systems with Apollo 6 the following year. And then, think about this, less than 2 years after Apollo 4 proved the whole concept was viable, Apollo 11 actually put boots on the lunar surface. Today, the real legacy of Apollo 4 lives on in the absolute, non-negotiable necessity of testing and validation. We always remember the famous quotes, and we picture those first footsteps. But behind those highly visible historic moments are these quiet, uncrewed triumphs. Great achievements always require a foundation of grueling, meticulous preparation. Apollo 4 didn't have a crew to celebrate, but without it, there simply is no moon landing. And that leaves us with a pretty fascinating question to consider for our own lives. When you look at your biggest goals, what invisible foundations are your greatest achievements built upon?